Hi, Bob here. This is a short video of my scroll frame skeleton clock in operation. I finished making this clock in 2002 and it is another of the clocks I have made based on designs by John Wilding. This skeleton clock is an 8-day clock, which means it runs for a week between windings. The height including the glass dome is 21.5 inches, which is over 50 centimetres. The name skeleton clock is self-explanatory. Their manufacture is believed to have started in France towards the end of the 18th century. English clockmakers made them in large numbers throughout the Industrial Revolution and into the 20th century. Many different styles of skeleton clock were made. For some reason, some were made to represent cathedral architecture, and others were extremely elegantly designed with scrolls and curves reflecting the artistry and design of the Industrial Revolution. My clock is a relatively simple design known as a scroll frame. Because the mechanics of skeleton clock movements and the frames are on display, all parts had to be finished to a very high standard. Having said that, the silvering on my dial has started to break down in places, as you can see. I have left it for a while, judging that this made the clock look older than it really is. However, I think the time has come for me to re-silver the dial, which is a straightforward process. The glass dome is Victorian, which I had to purchase. It is essential for keeping the dust out. Glass domes like these are becoming increasingly scarce and expensive. The clock frames are made of brass. These are cut by hand and then filed and finely emery papered down to an outline. The main spring is contained in the barrel at the bottom of the clock, and this in turn is connected by the wire cable to the cone-shaped fusee. The purpose of the fusee is to help compensate for the loss of power as the mainspring winds down over the course of a week. I'm going to move the clock without the dome onto my movement test rig so that you can more easily see it. The clock has a passing strike, which means that the bell at the top of the clock is struck by the hammer once each time the minute hand passes the hour. Some skeleton clocks have no strike feature, whereas others strike the number of hours, bang on time. The cast bronze bell is one of the few parts I didn't make. I purchased it from the Whitechapel Bell Foundry. The Whitechapel Bell Foundry was the oldest manufacturing business in Great Britain until the foundry finally closed in 2017. It had been in continuous operation for nearly 450 years. Whitechapel made many church bells and other distinguished bells, but its most famous bell was Big Ben, which was made in 1858 and weighed in at over 13 tons. Anyway, I'm extremely proud that my clock has this great association with the historic Whitechapel Bell Foundry. Here is a view of the back of the clock. The pendulum maintains accurate time. By adjusting the pendulum upwards, the overall length is shortened, which increases the frequency of oscillation, making the clock run faster. Adjusting the pendulum downwards, the opposite is true. Well, there it is, a very brief view of my skeleton clock. In later videos, I will look at other clocks I have made and also some of my restoration projects. Thanks for watching. Bye for now.